Hello, geometry class for Tri-City Christian Academy 2020. I wanted to make a short little video about question 16 for section 8.2, page 355. So if you want to pause right here and open your book to that, that would be great. I'm not sure anybody got this right. That's right. I'm not even sure Jason got it right. One person might have been close, actually. I'll check on that. One of you might have got it right. But anyway, most of you got it wrong. So I wanted to do this quick little discussion. So again, external tangents, common external tangents, are ones that are going to not touch a segment that would join the centers of two circles. Okay? So I want you to imagine in your mind any two circles. You draw a segment connecting their centers, and as long as you have tangents that are touching outside of that segment that's connecting, these are common external tangents. And so you'll find them at the top of page 354. The diagram on the right is the common external tangents. Okay? So here's question 16D and E. 16D, how many common external tangents to figure A? And 16E, how many common external tangents to figure B? So here's figure A and here's figure B. Now, a lot of you, your answer was like 2 or 4. And the reason you gave that answer is because you were only putting them on the outside of the entire diagram, okay? And what you were forgetting is that we're not talking about external tangents to two circles or pairs of circles, but any two circles. So for instance, take a look at the top circle in letter A and the left circle, okay? So let's think of this as like the northwest quadrant with these two circles. So you can see right there, I can draw two diagonal external tangents. And then if I take the top circle and the one on the right, think of this as your northeast quadrant, I can draw two diagonal external, okay? So you have to think of these pairs of circles independently. But guess what? That also means that I can have external tangents, again, as long as they're not touching the segment that would go between two circle centers, but that doesn't mean that they couldn't intersect other circles. So guess what? Let's think of the top circle and the bottom circle. Look there. Guess what? I've got two common external tangents that I could draw there that would happen to intersect the circles on the right and the left, but they would still be commonly external to the top circle and the bottom circle. So that's what you've got to realize, is that every pair of circles, any pair of circles, any two circles, as long as they are not internally tangent or one within the other, that was one of the answers, by the way, for if you couldn't find any common tangent, internal or external, that was having one circle inside of another and not touching anywhere on it, okay? But for these, because these are not like that, you've got all kinds of common external tangents, because not only do I have diagonal ones that I have for letter A and for letter B, but I've also got vertical ones between the top and the bottom one, and I've got horizontal ones that can go between the right and the left one. And then letter B, what's interesting about that is because now you've got an even greater overlap between these circles, I actually can create even more external tangents, as you'll see when we get to the answer. And so the reason is because I have even more diagonal tangents that I can draw. For instance, if you think about the one on the left in letter B and the one at the bottom, I've got diagonal ones on both sides of that. And now if I move up to the top one and the one on the right, I've got an additional diagonal there. So you actually have more in letter B that you can create with the overlap. So the answer looks like this. So again, you look at letter D at the top, not only do I have those outside tangents, but every two circles has tangents between them diagonally, but also horizontally between the right and the left one, and vertically between the top and the bottom one. And then when I do the overlap on letter E, I can actually create more diagonal tangents between these circles. So what's the final answer? Well, you can count them there if you want to, but the answer is 10 total external common tangents in letter D and 12, an extra 2 that I've created because of the overlap of these circles. So I just want to make sure that you understood this concept. I don't know that there's going to be anything quite this complicated on your test, but I did want to make sure that you understood that anytime you've got pairs of circles that are external to each other, you're going to be able to create common external tangents between them. All right, thank you.